Welcome to the Titus Timeout podcast. My name is Randy Zimmerman, and today I'll be discussing CV ratings for water valves. Valves are used to control the flow of water through many types of HVAC equipment, like terminal units, room fan coils, and chilled beams. These valves can either provide modulating or two-position on-off control for heating and cooling coils. These valves can also be configured to provide two-way or three-way control. In order to properly size a water valve, we first need to know how much water volume we'll be controlling. Water volume is generally expressed in terms of gallons per minute, or GPM. Every valve body is flow rated in terms of a flow coefficient, or CV rating. The CV rating indicates the number of GPM that a valve body can handle with a pressure drop of 1 psi in a fully open position. We can relate CV to GPM and pressure drop using the following equation. CV equals GPM divided by the square root of the pressure drop. Care should be taken to ensure that control valves are not undersized. If the CV rating of a valve is too low for the GPM to be controlled, excessive head losses could limit the flow of water through a coil. Even though designers tend to oversize pumps by at least 15% to handle unforeseen problems like this, there's really no excuse for making this kind of mistake. Undersized valves can create other problems. When pressure drops through valves get excessive, water exiting an undersized valve can cavitate. Cavitation can cause a host of problems because the resulting vibration and turbulence can prematurely wear out valve seats and seals. It can also cause weak joints in the plumbing to fail and result in noisy operation. So does it mean it's safer to always oversize water valves? No. Oversized valves can cause other problems. First off, an oversized valve will require some sort of balancing valve to limit the water flow through a coil. Too much water passing through a coil can actually reduce the heat transfer capability. More importantly, an oversized valve will likely have control issues. The valve may only need to crack open to achieve design flow. This means that a modulating valve may behave more like an on-off valve. In addition, an oversized valve will tend to hunt back and forth attempting to maintain control, resulting in premature actuator failure. Let's look at an example. Let's say you have a line of valves that offer CV ratings of 1, 2, 3, 4, and 5 to choose from. You've determined that the maximum water flow will be 4 GPM and the desired maximum pressure drop is 2 psi. So we fit this into our equation, and we calculate that our CV rating should be 2.8. So the best choice for this application would be CV rating of 3, because that's the closest value to 2.8, and we never want to undersize a valve body. Just to summarize, a properly sized valve should be quiet, provide accurate flow control, have long service life, and it shouldn't leak. Selecting a valve body for the correct CV rating is critical to making all of these things happen. Thanks for tuning into our podcast. I hope that this information is helpful. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.